In this video, we're going to talk about geometric sequences. So the way that we define a geometric sequence is by a common ratio. As an example here, suppose you have a cost of living increase in your job, and that way that it always is consistent with the inflation. So at least every year, you may not be making more money, but at least you're not losing money because of inflation. Now suppose you're a recent college graduate and you find a position as a sales manager earning $26,000. I would probably tell you probably want to find a different position, but $26,000 I guess is better than going in debt $26,000, and he is promised 2% cost of living increase each year. His annual salary in each given year is found by multiplying his previous salary by 102%. So in other words, what he's doing is you are multiplying by each one of your salaries in an equivalent decimal as one of his current, and then that 2%. So you take 26,000, multiply it by 1.26, and that's going to tell you what he's going to get that next year with that increase. So after year one, he gets 26,520. He then multiplies that again with the 1.02, and he gets 27,050 and 40 cents change. And then the next year, he's going to get 27,591, and that's going to continue. This is increasing at a constant rate, not a constant amount. Because it is increasing at a constant rate, this is going to be a geometric sequence, because the constant rate, the rate in which it increases each year, we're going to call that a common ratio. If that happens from term to term in our sequence, then it's a geometric sequence. If you were told that a sequence is geometric, do you have to divide every term by the previous to find it out? And the answer is no. They're telling you it is geometric, so you'd say, okay, cool. All I have to do then is find my A1 if it's not given, which we'll have a couple of those where it's not given. This is the formula generically for a geometric sequence. A sub n is equal to my first initial number, and then r raised to the n minus 1, my first initial term in my sequence. So if I'm trying to determine if it is a geometric sequence, if I'm given a list of numbers and I'm trying to determine if it's a geometric sequence, is I need to find that common ratio. And the way that I do that is I look at the previous term and divide it. I take a look at the second term and divide it by the first, the third by the second, and etc. So I take the term and divide it by its previous term, and then I compare it. So A1, A2, A3, A4. So what I'm going to do is I'm going to compare A2 divided by A1. This is 10 divided by 25. Does that equal the same thing as A3 divided by A2? Well, A3 is negative 5 divided by A2 is 10. And the answer is no. I've got this is going to be 2 over 5, and this is going to be negative, ignoring even the negative, is going to be 1 over 2. So the answer is no. It is not geometric. So no. Let's take a look at our next one. Again, we're going to do my A2 divided by A1. So I have 20 divided by 100. This is my A2 divided by my A1. I'm going to ask myself, does that equal A3 divided by A2? My A3 is 4, my A2 is 20. Well, 20 divided by 100 is 1/5. So this equals 1/5. 4 divided by 20 is also 1/5. So far this is looking good. I'm just going to check one more because I can. And so I'm going to take my next one and check to see, does this also equal a the 4th over a3? A4 is 4 over 5. A3 was 4. And of course, this reduces down to 1/5 as well. So this is a geometric sequence. Using the fact that I know that a sub n is equal to a1 r raised to the n minus 1, this value, this ratio that remains the same, is my r. So my a sub n is equal to my initial term, which is 100, multiplied by 5 raised to the n minus 1. And you're going to ask me, can I clean that up? And absolutely I can clean it up algebraically, or I can just leave it like that. Let's take a look at my next example. So I'm going to look to see, I'm going to ignore the fact that it's alternating because it's negative, positive, negative, positive. Oh, no, they're all negative, so, they're all negative. Cool. I don't have to worry about it being an alternating sequence. So I'm going to check my a sub 2 divided by my a sub 1, which is negative 0.5 divided by negative 2. I ask myself, is that the same thing as negative 0.125 divided by negative 0.5? Which is a3 divided by a2. Well, negative 0.5 divided by negative 2 is equal to a positive 0.25. That's what that side equals. And then I take the negative 0.125 divided by the negative 0.5. That is also equal to positive 0.25. And I'll do the last one because we can. And so I'm asking myself, is the last one ratio holding up? Which is the negative 0.03125 divided by the negative 0.125, which is a sub 4 divided by a sub 3. This one I'm going to have to get my calculator out, so I'm going to do the negative 0.03125 divided by the negative 0.125, and it is indeed also the 0.25. So this is also a geometric sequence. And if they're asking me for my explicit or closed formula, it is going to be a sub n is equal to my first term, which is negative 2, multiplied by my ratio, which is 0.25 raised to the n minus 1. All right. So if I'm given the first term and the common factor, if I need to find the next 4 numbers in the geometric sequence, all I have to do is just put in 1 and put in 2 and put in 3 and put in 4 until I get all the terms. Just make sure I have commas where I need them and brackets if I need those as well. So if I am given several terms in the geometric sequence and I need to find it as a recursive formula, I'm going to state the initial term. Then I find the common ratio like I did before. Then I substitute the common ratio into the recursive formula for a geometric sequence. So let's take a look at these examples where they're asking me to find the explicit formula for the nth term. So in other words, they're asking us for the closed formula or the explicit formula. They already have all the information there, so all I have to do is a sub n, filling in the fact that I know that a sub n in general is equal to a sub 1 r to the n minus 1. That's a geometric sequence. So this is going to be equal to 8 and then 0.3 raised to the n minus 1. Cool, done. Now this one, we actually did these two up above, so I'm not going to do those again. What I am going to do is look at these. Now with these are slightly different because I'm not given my a sub 1, I'm not given my ratio. And the way that I'm going to approach these is I'm going to use the formula. The formula again is a sub n is equal to a1 r to the n minus 1. So my a sub n, which is the 7th, is equal to, so a sub n is equal to a1 r to the n minus 1. So my a sub 1 and my a sub 7 is 64 is equal to a sub 1 r. My n is 7, so 7 minus 1. So my first equation is 64 is equal to a sub 1 r raised to the 6th power. And then I'm going to use this information, same formula. 512 is equal to a sub 1 r raised to the 10, because that's my n, minus 1. So 512 is equal to a sub 1 r raised to the 9th. Now what I have is 2 equations and 2 unknowns. I'm going to take one of the equations and solve for a sub 1 because that's the one that has a power of 1 on it. So I'm going to take this first equation and solve for a sub 1. So 64 divided by r to the 6th is equal to a sub 1. So I'm going to then plug that into my second equation. So 512 is equal to 64 over r to the 6th. And then it's going to be r raised to the 9th. So what I have then, by the rules of exponents, is I have 512 is equal to 64 r raised to the third, because I'm going to subtract those exponents. I'm going to divide both sides by 64, and what I'm going to get is r to the third is equal to 8. And so I take the cube root of both sides, r is equal to 2. So now that I've found the r, I'm going to put that back into this equation here to find my a sub 1, and then I can just find my geometric sequence from there. So I'm going to take 64, I'm going to divide it by 2 raised to the 6th power, and I get a sub 1 is equal to 1. So I combine all this together and I get my closed formula. My closed formula is a sub n is equal to my a sub 1, which happens to be 1. I don't need it there, but I'm going to go ahead and write it. And then 2 raised to the n minus 1. So in other words, a sub n is equal to 2n minus 1. And there's my closed or explicit formula. Now let's go ahead and do this second one. Again, what I'm going to do is build 2 equations and 2 unknowns. I'm going to bring that over here though. My first equation is going to come from here. So 25 is equal to a sub 1 r, and remember my index here is 6, so it's 6 minus 1. 25 is equal to a sub 1 r raised to the 5th. My second equation here is going to come from here, and so I have 6.25 is equal to a sub 1 r. My index is 8, so it's 8 minus 1. So 6.25 is equal to a sub 1 r raised to the 7th. Again, I'm going to take one and solve for a sub 1 so I can put it in the other. So I'll do I'll do it the other way still. I want to stay with positive exponents. I don't want to mess with negative, so I'll go ahead and solve for a sub 1 with the one that has the smaller exponent. So 25 r raised to the 5th is equal to a sub 1, and it's no other reason, I just don't feel like messing with negative exponents. 6.25 is equal to, my replacement for a sub 1 is 25 over r to the 5th. And then I have the r raised to the 7th. Using my regular rules of exponents, I get 6.25 is equal to 25 r squared. I'm going to take 6.25, I'm going to divide by 25, and I get 0.25. So 0.25 is equal to r squared. Now I'm going to take the square root of both sides. When I take the square root of the left-hand side, I should put the plus and minus on. But I'm not going to, because my ratio is going to be positive. So my ratio will be positive. So I'm not going to put the plus and minus. I'm going to just take the positive. So I take the square root of 0.25 and I get 0.5. So my ratio here is 0.5. I'm going to put that back into here and find my a sub 1, and then I'll have my explicit formula. So 25.5 raised to the 5th power is equal to a sub 1. Get my calculator out. 25 divided by 0.5 raised to the 5th power, and so my a sub 1 is 800. So my closed formula is a sub n is equal to 800 r, which is 0.5 raised to the n minus 1. All right. So when I'm trying to find a specific term in a geometric sequence, I don't have to write all the terms out. All I have to do is put all the information in the right places. If they give me the a sub 1 and the r, then I just start with my explicit or closed formula. A sub n is equal to 2, 3 raised to the n minus 1. If I want a to the 5th, then this is simply going to be 2, 3, 5 minus 1. So 2 times 3 to the 4th, get my calculator out on that. So 2 times 3 raised to the 4th power is 162. And notice I'm not writing all of those out. Okay, let's take a look at this one. Now this one, I don't have a closed formula, so what I have to do is deal with the fact that it is an alternating sequence, that it's geometric. I know it's alternating because I can see the plus and the minus and the plus and the minus, so I know that in my a sub n, I better have negative 1. And I need the first one to be negative, so it's n, not n plus 1, it is going to be n. Then I just have to do is find my ratio and ensure that I'm going to do a sub 2 divided by a sub 1. And they're telling me this is geometric, so I just need to find one of these ratios. I'm going to ignore the negative. So I'm going to take 2/3 and divide it by 2, which is the same thing as 2/3 divided by 1/2, so that gives me 1/3. That's my r. So my first term is 2, and then I'm going to have my r, which is 1/3 raised to the n minus 1. Now all I have to do to find a sub n, or a sub 7, is -1 raised to the 7th power, multiplied by 2, 1/3 raised to the 7 minus 1, which is 6. And if they want an exact answer, then this is going to be -1 to the 7th power is going to be negative, multiplied by 2, so -2. And then I'm just going to get my trusty calculator out. I'm going to do 3 raised to the 6th power, which is 729. And that is the answer for that one. And I'm going to let you think about this one. How are exponential functions and geometric sequences similar? How are they different? And that's it. That's for this video.